For section 16.1, we are going to solve quadratic equations using square roots. So to begin with, we have a couple of properties to talk about. The first one is the product property of radicals. The product is your answer to multiplication. So when we have a number that is not a perfect square, so we can't take the square root of it and get a whole number, we can break it down sometimes and simplify it. So for example here, I have the square root of 45. 45 is 9 times 5. We can take the square root of 9, but we can't take the square root of 5. So when we take the square root of 9, we get 3, and we have the square root of 5 left over. So it's 3 square roots of 5. So when you're doing that, you need a list of the perfect squares. So it's 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are the first 10 perfect squares that you can use to break down radicals. That list is kind of important. The quotient property of radicals is very similar, except for now we have fractions. And so if we have 0.07, which is 7/100ths, we can turn that into a fraction with the square root of 7 over the square root of 100. We can't simplify down the square root of 7 anymore. 7 is a prime number, and it's not a perfect square. But the square root of 100 is actually 10, so we can have square root of 7 over 10. Now, the other thing I want to talk about is when you do take square roots, you get a positive and a negative answer. So you have to keep that in mind that there's actually two answers when you do the square root of something. So this one, simplify the square root of 12. We are going to break 12 down into two numbers. 1 has to be out of that list of perfect squares. So we can do 2 times 6 or we can do 4 times 3. And 4 is in that list, so we want to do 4 times 3. The square root of 4 is 2. And then the square root of 3, we can't do anything with. 3 is a prime number. We can't break it down, and it's not a perfect square. So it's actually positive and negative 2 square roots of 3. So just don't forget there's two answers when you're doing square roots. This one is division, so we can break it up into the square root of 16 divided by the square root of 9. Both of these numbers are in our list of perfect squares, so we just take the square root of them. So the square root of 16 is 4, and the square root of 9 is 3. And remember, it's positive or negative 4/3. And then this one, 0.27 is 27/100ths. So we have the square root of 27 over the square root of 100. We already know the square root of 100 is 10. 27 is not a perfect square, so we want to see if we can break it down using that list of numbers. The largest number that we can use to break down 27 would be 9 and 3. So 9 times 3 is 27. 9, the square root of 9 is 3. And then the square root of 3, we can't break down any farther. 3 is a prime number. So it's 3 square roots of 3 over 10. And remember, it's positive and negative. All right, a quadratic equation. So when you see something in, oops, it will not move for me. There we go. A quadratic equation is an equation that can be written in standard form. Ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a can never be 0. So I wrote an example there in pink underneath. That is something where a, b, and c are numbers, and that's what some of our problems are going to look like, or very similar to that. So in order to solve these, we need to solve for x squared is what our whole goal is. So for this equation, we're going to do the upside down t. We're going to add 8 to both sides. So this side's going to be 2x squared, and this side 0 plus 8 is 8. Then we're going to divide by 2. So x squared equals 4. And then our last step, to get rid of x squared, we take the square root. So x equals, square root of 4 is 2, and it's positive and negative 2. There's two answers there. And then b, I forgot the equals 0 part. We have to add 9. So we have x squared equals 9, and then square root. So x equals square root of 9 is 3, and it's positive or negative 3. And then C here, we are going to add 128 to both sides. So 2x squared equals 128. Then we're going to divide everything by 2. And x squared equals 64. And then to solve for x squared, we take the square root, so we want just an x, and the square root of 64 is 8. And there's always two answers, so positive and negative 8. So basically, when we solve quadratic equations, we are solving for what's called zeros, and we're looking for where they cross the x-axis at if we were to graph these quadratic equations. And remember, a quadratic equation looks like a U. So sometimes it would cross the x-axis in 2 different spots. It could look like that. It could cross in one spot where it was just sitting on the x-axis, or if the x-axis was farther down, it wouldn't touch the x-axis, so there'd be no solution there. So that's always an option as well. So we're either going to have 2 answers, 1 answer, or no answers. All right, and then for our last 3, we're still doing the same thing. We're solving for x, except for this time we have the quantity of x plus 5 squared. Just our x is not squared. So what we have to do here is take the square root first to cancel out that squared. So we would have x plus 5 equals, and then the square root of 36 would be 6, but remember it's positive or negative 6. So we actually have 2 problems here. We have x plus 5 equals positive 6, and we have x plus 5 equals negative 6. So I'm going to subtract 5 on both sides of both equations. And I'm going to get x equals 1 here, and I'm going to get x equals negative 11 over here. So those are our 2 answers for this question. Okay, this one has a 2 out front of the parenthesis, so we got to divide by 2 first. So we would be left with x minus 3 squared equals negative 32 divided by 2 would be negative 16. And then we take the square root of both sides, which would cancel out the squared. So we would have x minus 3 equals the square root of negative 16. Now we can't take the square root of a negative number because there is no number times itself that is going to give us 16. We have 4 times 4, which is positive 16. And we have negative 4 times negative 4, which is again positive 16. But if we had one of each, that would give us negative 16, but that's not the same exact number. So we can't do that. That's not the square root. So this one is no solutions. This quadratic, this parabola, does not touch the x-axis. And then for this one, our last one, we are going to divide by 3 first to get rid of that. And we would have x minus 5 squared equals 6. And then we can take the square root to get rid of that squared. So we have x minus 5 equals the square root of 6. Now, square root of 6 is not a perfect square. It can be broken down into 2 times 3, but neither of those are perfect squares. So we're just going to leave it positive or negative square root of 6. So I still have 2 answers, so I have to break it up into 2 different problems. So I'm going to have x minus 5 equals a positive square root of 6. And I'm going to have x minus 5 equals a negative square root of 6. Now, in the problem before, we said we couldn't do a negative. That's when it was underneath of the radical. This one is outside, so it's like a negative 1 times square root of 6. So we can work with that. Just can't work with it when it's underneath the radical. So this one, we're going to add 5 to both sides. So we're going to have x equals, and we have a positive 5 and a positive square root of 6. for this one, we have positive 5 and minus square root of 6. So notice they're very similar except for there's a plus, one's a plus and one's a minus in the middle. So what we can do is write 5 plus or minus square root of 6 for our answer. And I always put that constant, that normal number out front, because if we put it behind it, it sometimes looks like it might be underneath of the radical, and that's not the answer. It's not 6 plus 5, the square root of 6 plus 5. It's 5 plus the square root of 6. So that's why we always move it to the front to alleviate that confusion.